Hi there. So I want to introduce this new set of videos that talks about this slightly modified Teensy breadboard bot that I've put together, and kind of summarize some of the changes, and we'll get started on some of the basic programming and construction. I will say this set of videos is going to be quite a bit shorter than the previous set. I might reference the set because I don't want to get into a whole programming tutorial. I'm going to give little snapshots and snippets of programming and focus on trying to get this guy assembled as quickly as possible. A couple of key points that are different from the previous ones. The most noteworthy is that I decided in this case to go ahead and get one of these pre-assembled breadboard power supplies. They're really pretty nice. You can select them between 5 volts and 3.3 volts. They slot right into the breadboard very nicely. They have a nice power switch, which is really handy. The other thing is that I've moved more to 3D printed parts. The sensor mount and the bumper sensors are all 3D printed, so you don't have to deal with all the manipulation of trying to line up all the holes and the screws for the wires for the bump sensor. I don't have a sensor on here right now. Depending on which one you get, it's going to have either an ultrasonic or a sharp sensor. Other changes, again, because 3D printing, one of the hassles, one of the things I didn't like about the original one was the sort of clamshell clamps that held the motors in place, but now I actually 3D print these adapters here, which fit really nice, and they eliminate all the hassle of trying to mount the motors and all the slop that was with them originally. Another change is the wiring. There isn't so much of this fine wiring. There's still some. I think it's an important skill to have, to be able to trim a wire, cut it, and fit it and place it and have it laying flush. So you'll see a number of small pieces of wire that go on. But ultimately, I'm going to be using a larger number of these sort of stripped off ribbon cables. The downside of this is that the colors are not reproducible. So your purple might be my green. It's really, you have to follow the wire rather than follow the color. But they are remarkably affordable, easy to use, and robust. So there's going to be some more of this ribbon cable wiring on there. I think that's really about it. There's still going to be some of this discrete wiring going on. I'm going to have some placement of some parts a little bit differently. And basically, though, it's going to still be the same functionality. We should be able to get to a sumo plane robot with line follower detectors. I might have two different types. I'll show you how to use either one. I've got these with the 2 emitters and these with the single emitter. They both work very well, and they're remarkably easy to use, fully analog, none of that digital, dialing it in stuff. You can go ahead and set them for the value exactly what you want. So with that being said, I think I'm going to break from this introduction and get started on the breadboard layout. So I will see you in just a few seconds. Okay, so let's kind of tentatively lay out this breadboard so that everything kind of fits. So one of the most important things to sort of work around or deal with is the layout of this power supply. Okay, and if you look carefully, if I can get this to zoom in, autofocus, it's not doing the best job, but you'll see that this outer one here is a positive and the inner one here is a negative. And what we want to do is we want to make sure that the positive and negative correspond to the red and the blue stripes. I think it makes perfectly logical sense. Which means you have to look carefully at your your breadboard. Some of these breadboards are like this one. Some of them have the high numbers on one side going low numbers on the other, so they're inverse, which is really nice. But what we really need to do is we want to have it so that the input portions of this board hang off the back of the board. So in this particular case, on this particular breadboard, and again, you're going to have to look at yours, I'm going to have the red positive, okay, on the outer end of this board, which means that I'm going to be forced to stick it like this, so the red positive matches to this red stripe, which unfortunately means in this board, may not be your case, but in this board, that the numbers go from low to high, which means that when I start placing components, I'm going to be doing it kind of opposite what is intuitive. So let's look at a couple of the components. The major components we want to place, of course, the Teensy. We're going to have to place the motor driver. I'd like to have this tricolor LED on here for experiments and diagnostics. And we want to have some room for a battery pack so that all of this can be strapped down on top of your robot chassis. So that being said, if I want to have this guy in the front, which I think makes good sense, if I'm just going to place it in here, you can see it's going to take 4 positions right off the bat. Okay, so it's a 4-wire device. I'm going to put it as far forward as I possibly can. It puts it right here. Now, the Teensy, it would be nice for demonstrations and for relaying information to you guys if we can come up with a standardized placement with the numbers. So I think what I'm going to do is I'm going to say, I'm going to put mine, again this might be different for yours, I'm going to put this lowest portion here, pins 12 and 13, I'm going to have it line up with, on my board is 45. Okay, so that gives it plenty of room up front to have this tricolor LED and maybe something else, maybe another LED indicator, and I can still access the cable, which is going to be important. If the battery sits someplace back here, I think I'll probably go ahead and place the motor driver. Notice the notch, okay, in the front of this. There's a little notch on the chip. I'm going to have it facing the front or facing the Teensy, and I'm going to have it span. I'm going to go ahead and just stick it right here so it begins at 40, something like that. Okay? So that being said, I've got a basic layout plan set up. There's actually no particular reason why I need this here right now, or actually this, or even this. We're going to start with something really simple. So that being said, if you already feel very, very confident in your ability to program with Arduino to a Teensy 3.2, and you know how to set it up and everything else, I'm going to say, hey, why don't you go ahead and skip the rest of this video and go right to the next one, because I'm going to start building and building and building. If this is the first time you've done it and you want a quick little introduction, continue watching. But I'm going to go ahead and pause it, set things up, and I'll see you in a second. Okay, so I'm going to set this guy up real quick. I'm going to plug it into my USB cable, like so. And I'll go ahead now and open up Arduino. I'll probably pause it here because sometimes it takes a while. Okay, so I've got Arduino open. This is a Teensy 3.2 that I'm playing with, so I'm going to go to Tools. I'm going to make sure that I have Teensy 3.2 selected. If you don't even have these options here, I'll send you a link to how to get that set up. You have to download something from the people that make this device, PJRC, and there's a download and an installer that integrates into Arduino, which works really nice. The next thing I'm going to do is go ahead and select the COM port. It should have Teensy written on it, so in this case it's Teensy 5. I'm sorry, not Teensy 5. It's COM port 5, what I'm using right now. And so let me go ahead and put in a little bit of code here so we can do a simple little test. First thing I want to do is I want to make sure that I've got a serial port open. Okay, so that's going to be a standard 9600 baud. It's a nice, slow, easy port. It's pretty routine. And let's do something really simple. Let's just do a we'll do a serial print, and I'm going to go ahead and say hi there. All right, simple piece of code. I'm going to load this. Now it's the first time, so it might take, you know what I'm going to do? I'm going to save it as something like delete me. You can save it as something more logically, but I would rather just kind of get rid of it. So I'm going to save it as delete me and replace this. First time running, it takes a little while to compile. I'm going to pause this and wait for it. Okay, so you see the Teensy loader has uploaded here, and the entire software has been uploaded to the Teensy. So if I go ahead and hit the serial monitor, you'll see, oh my goodness, look at that, it's flying by here. It's printing hi there, hi there, hi there on the same line as fast as it possibly can, which is kind of crazy. It might actually seize up my machine, it's going so fast. So I'm going to stick a delay in here. I'm going to close this, and I'm going to throw a small delay. Let's make it 500 milliseconds, or half a second. And I'm going to load it again. Now we should see it print at a little bit slower pace. I'm going to go ahead and open this back up. Oops, I opened it too quickly, so sorry. Alright, so now it's printing it. And you'll see it's on the same line. Well, that's not particularly cool. So it'd be nice if it was printed on new lines. That's a simple syntax right here. Let's just put in LN for new line. We'll load this up. And now you can see it printing hi there on a new line every half a second. Okay. The other thing would be kind of nice to do is to go ahead and load it so that it flashes the onboard LED. If you look at the layout of the Teensy, you can see that pin 13 has a LED built on. Okay, so let's go ahead and turn that on and off every time it says hi there, which is really pretty easy to do. The first thing we have to do is we have to set the direction of the port where the pin is to an output. So I'm going to go ahead and put that as pin 13 output. Okay, so now I can send data out that pin. And let's do this. Let's just sit there and do a digital write. And what are we going to digital write? We're going to digital write to pin 13. We're going to make it high. Okay, so we're going to say, hey, I want to send power out the pin. And then what we're going to do, sorry, after that half a second, we're going to take it and turn it low. Okay, turn it off. Now, actually, I'm going to run this and you'll see something strange, maybe a little surprising. So that should be on, that should be off. And you can see the light is always on. It's still flashing every half a second, but the light remains on. That's because we didn't give it an off time. So now it's going to be on for half a second and off for half a second. Let's load it up. And there you can see it. Okay, so let me end this right now and we'll start building on the board, and I'll see you guys in a second.